All right, guys, welcome back to another exciting day of geometry. As promised, I said I would finish up these notes which we started the other day. We looked at measurement in 3 dimensions, and we're just looking at the surface area of prisms. And again, that came about in 2 ways. It came about with something called lateral area. This is just the area of the sides of the box. So just the sides of the box is the lateral area. And we found that by doing the perimeter of the base times the height. Then the other measurement we did was total surface area, or just surface area, and that includes the sides of the box and the top and the bottom. And we learned how to do that on different shapes. You had homework assignment on it, you had an ed puzzle on it, so on and so forth. But today we're going to kind of add on to our two-dimensional measurement, and we're going to change to a different shape. And the shape we're going to look at today is a cylinder. So a cylinder is basically, I like to think of it as a prism. It's kind of like a circle-based prism. So kind of like a circle-based prism. So basically the bases are always going to be circles on a cylinder. Remember, it's a non-polyhedron because it's not made up of polygons, but they're going to behave just like a prism does, except that the bases are always going to be circles. And again, we'll look at the lateral area first. The lateral area is just the curved side of the can, basically. So if you kind of unrolled it, that creates your lateral area. Again, it's going to mimic the lateral area for a prism. Remember, lateral area for a prism was what? The perimeter of the base times the height. Well, if the base is always a circle, and I want to find the perimeter of the base, I'm basically finding the circumference. So the perimeter in this case is always going to be a circle, and so it's always going to be the circumference. Circumference you could find by doing what? 2 pi r. So 2 pi r. That's basically your perimeter of the base, which is always a circle. And then the height is going to be the dimension connecting the two circle bases. So this would be 2 pi r h. So it's the same formula. It's just that the p is replaced with the circumference formula because the perimeter of the base is always a circle. So that's the lateral area. The total surface area, that is the curved side and the top and the bottom. Remember, the top and bottom are always going to be circles. So now it's going to be the curved side of the can, and now I'm going to add on the two bases. So this will be the sides, 2 pi r h. And then I got to add on to it 2 circle bases. Well, the bases are always going to be circles. The area formula for a circle is pi r squared. So it'll be plus 2 pi r squared. So those are your 2 formulas. Here's your lateral area formula, which shows up in the surface area formula, and then you got to add on 2 circle bases. So that 2 is coming from the fact that there's a top and a bottom, and then pi r squared is the area of a circle. All right, let's see if we can use these. So here I have a cylinder with a radius of 3 and a height of 5. So we're using the lateral area formula, which is what? 2 pi r h. Got 2 pi. My radius is this 3. And then the height is that 5. So at that point, I can just go right to my calculator and plug all that in. And we'll round to the 10th on these. So let's see, 2 times pi times 3 times 5. So that is 94.2. There's a 4 behind it, so I don't have to go up. So that's 94.2. Do I have units on this? Inches squared. So that's the lateral area. Now the total surface area, again, is 2 pi r h, which I just found. And then I'm going to add on to it 2 circles that are both pi r squared each. So let's see. I just found this to be 94.2. So no need to redo that. And I'm going to add on to it 2 times pi times, my radius is still 3 squared. So I'm going to use that number on my calculator. Remember, if I just hit the plus button, it's going to take whatever was in the previous line and add on to it. That's what A and S means. So then I'm going to do plus 2 times pi times 9, which is 3 squared. And so that gives me 150.7, but there's a 9 behind it, so I have to go up to 8. So 150.8 inches squared. And your surface area should always be bigger than your lateral area, just so you know. So that's one problem. Here's another problem down here. So now I have a diameter instead of radius. Well, if the diameter is 4, that means my radius is going to be half of that, or 2. So now using 2 pi RH would be 2 pi. My radius is 2, and my height is 6. Plug it all in. 2 times pi times 2 times 6. So again, that'll be 75.3, but there's a 9 behind it, so I got to go up to 4. 75.4 inches squared. So down here, I'm going to do the same thing. It's going to be the 75.4, which is the lateral area, just the sides, and I got to add on the top and the bottom, which are both circles with a radius of 2. So pi 2 squared. So again, I'm just going to hit the plus button. 2 times pi times 4, which is 2 squared. And so that's 100.5. And that's inches squared. Yeah, I'll stop at 5 because there's a 3 behind it, so I don't go up. So again, that'll be your homework is practicing lateral area and surface area of these circle-based prisms called cylinders. So again, the one formula for the sides of the can are going to be 2 pi RH, and then the total surface area is going to be that plus the 2 circle bases, which are pi r squared each. So practice using that, and I'll put the homework up and the answers to the homework so you can check your answers. Again, if you have any questions, please stop in at office hours or send me an email. See you soon.